Okay guys, today we are looking at Unit 2.5 notes, and that is dealing with vertical and horizontal shifts. The learning target is I can identify the shifts that are created by f of x minus c and f of x plus d. So before we get to any kind of shift, we are going to look first at f of x equals 3x plus 7. This is in slope-intercept form, meaning the slope is in front of x, or m, that is 3. My slope is 3. My y-intercept, which is b, is 7. So m and b. The way we graph that equation on a graph is first by plotting the y-intercept. Which in this case is 7 on y-axis. So I put that here. And then what I do is use my slope as rise over run to create more points. So 3 is a whole number. I can turn that into a fraction by putting it over 1. So 3 is my rise. So I'm going to go up 3. 1 is my run. So from my y-intercept that I have already plotted, I go up 3 and over 1. And then do it again. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. The more points you create, the more accurate your line is. Once you have multiple points, you connect your points to create your line. So that was just a quick review of how to graph an equation that is in slope-intercept form. So now we're going to move on to the actual shifts. So the first equation that I have is f of x, which we know is y, equals x. So my slope here is what's in front of x. I don't see anything, and I know the only number I can add there is 1. I don't have a y-intercept or a b, so I put 0. And that's the equation that is already graphed there. It's known as the parent function. So now I have a second equation. I have g of x equals f of x minus 4. Well, we know that f of x is x, so really what I'm looking at is just x minus 4. Again, my slope, there's nothing in front of x, so I write a 1. Now, my y-intercept is negative 4, because now I have something that's attached to the x after it. So I'm going to take the same concepts that I used up here. I'm going to plot my y-intercept first and then use my slope to create additional points. So my y-intercept in this case is negative 4. So from the origin I go down 4 because it's negative. 1, 2, 3, 4. Now my slope is 1. To turn 1 into a fraction, it's 1 over 1. They're both positive, so I'm going to go up and to the right. So from the y-intercept that we have already plotted, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And you can see that the points are going to create a perfectly straight line. We connect those points to create our new line. And that is the line for the equation f of x minus 4. So we're going to look now at f of x plus 4. So this is the same as this. So my m is still 1. My b is still 0. My slope is up 1 over 1, up 1 over 1. It's going through the origin, which is 0. So now I'm looking at x plus 4. So nothing has changed in the slope. So my slope is still 1. my b is positive 4 instead of negative 4. So on my y-axis, I'm going to find positive 4. So from the origin, I go up 4. That's my y-intercept. My slope, I can use this. It's the same thing because my slope is 1. So up 1 over 1, up 1 over 1, to show we have a slope of 1. Connect our points to create our line. Now, we're going to focus on what is happening horizontally to the original line that we had. So how does the sign inside the parentheses affect the horizontal movement of the line? Well, let's look at the first one that we had on the inside. So on the inside, we had minus 4. And now remember, horizontally is sideways. So if I started here, the only thing that changed was my y-intercept. So if my y-intercept was here, and I'm looking at horizontally, my line moved to the right. So when I had minus 4, my equation, the line moved to the right. When I had a plus 4 on the inside, the opposite happened. So horizontally, my line moved to the left. So when you are dealing with a plus or minus on the inside of the parentheses, the opposite happens. So when the sign is on the inside, the horizontal movement is the opposite. And that's important, of the sign. So when I had a minus, it moves to the right. When we had a plus, it moves to the left. So normally on a number line, the positive numbers are on the right, the negative numbers are on the left. But when it's on the inside, it's the opposite. So a minus 4 on the inside is actually going to cause it to move right. A plus 4 is going to cause it to move left. So does the shift or translation affect any other part of the graph? So the only thing that changed, and I can look up here, is the y-intercept. My slope stayed the same. So does the shift affect any other part of the graph? No. Only the y-intercept is affected. So that was dealing when we have the signs on the inside of the parentheses. And remember, they are the opposite. So now we're going to look at some shifts, but when signs are on the outside of the parentheses. So starting with the same parent function, my slope is 1, my y-intercept is 0. It's already graphed for me. This time I have minus 4 on the outside of the parentheses. But if f of x is x, then I still have x minus 4. Nothing in front of x means my slope is 1. My y-intercept is b. That comes after the x. It is minus 4. So again, I'm going to graph the negative 4 first because that's my y-intercept. And my slope is 1 over 1. I go up 1, right 1. Positive both ways. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And you can keep going. When we have our points, go ahead and connect them to create our line. Now I'm going to do the same thing for 7 and 8. This is still the parent function. My slope is 1. My y-intercept is 0. That's already on the graph. This time I have a plus 4. So my slope is 1. My y-intercept is positive 4. So from the origin, I go up 4 because it's positive. And then my slope is still 1, so it's still the same thing as up 1, right 1. Up 1, right 1, up 1, right 1, up 1, right 1. And it's the same thing because the slope isn't changing. So again, I connect my points. Now, this time, we're going to look at how the sign on the outside of the parentheses affects the vertical movement of the line. Vertical is up and down. So if this is where my line was, it has to move either up or down. So when I'm at -4, if this was my original line, this time it moved down. So it's like if I just took my line and shifted it down. Up here we had +4. So if this was my original line, it moved up. So again, it's like if I have this line and I just shift it up. So how does the sign outside the parentheses affect the vertical movement of the line? The sign on the outside shifts or translates so it shifts the line in the actual direction of the sign. Meaning plus is going to equal a shift up, minus is going to equal a shift down. And I'm actually going to go back to the previous examples because this was the opposite. So when we're looking inside the parentheses, it was the opposite, meaning a minus is actually going to equal a shift to the right, and a plus is actually going to equal a shift to the left. So when it's inside, it's the opposite. But when you're looking at the sign on the outside, it's the actual direction of the sign. So does the shifts or translation affect any other part of the graph? The answer still here is no, because the only thing that's changing is the y-intercept. So we have a couple more graphs, still starting with the parent function. By now, this should be fairly easy. My slope is still 1 because the only number I can write in front of x when there is no number is 1. My y-intercept is 0. I have nothing after the x. So this time I have the sign on the inside of the parentheses. So f of x is the same thing as x, so I have x plus 5. My slope is 1. My y-intercept is positive 5. So according to my y-intercept from the origin, I'm going to go up 5, put my first point there, and then use my slope as a fraction. So up 1, right 1. And then connect the points to create my line. Again, I still have the parent function. My slope is still 1. My y-intercept is 0. If you notice, we have the same. We're starting with the same graph for every example. So the slope and the y-intercept for each of the first equations should all be the same because we're starting with the same graph. Here I have f of x, which is x, so I still have x plus 5. So my slope is still 1. I haven't added any number in front of x. My y-intercept is 5. So this here is the same as this. So from the origin, I go up 5. My slope is still 1, so I'm going to go up 1 over 1 to the right. Up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. Connect your points to create your line. So I have two graphs that look exactly the same. So how are the graphs similar? Well, they have the same slope and the same y-intercept. How are they different? Well, they're not different. The difference is the way we look at the shift. So remember that when we have the plus or minus on the inside, it is considered a horizontal shift. So when they're on the inside, it's the opposite. So I'm looking at how it moved this way because it's on the inside. So it's a plus 5, which means I actually move to the left. This has the plus 5 on the outside, which means it is a vertical shift. And when it's on the outside, it's in the actual direction. So plus 5 means I move up 5. So the graphs are the same, but the shifts are different. So even though the graphs look exactly the same, you need to pay special attention to whether your sign is on the inside of the parentheses, causing a horizontal shift, or whether it's on the outside of the parentheses, causing a vertical shift. So this is a horizontal shift, but this one is considered a vertical shift. Even though they look the same, because the equations look different, they're considered to be two different shifts. One is left, one is up. So another example, the last example, and this is pretty similar to the previous one. In the last one we had x minus 5, or I'm sorry, we had x plus 5, now we have x minus 5. So my slope is still 1, my y-intercept is still 0. My slope is still 1, except here my y-intercept is going to be minus 5. So in the previous example we were going up 5 because it was positive. Here I'm going to plot negative 5 on my y-axis because my y-intercept is negative 5. My slope is still 1, which means up 1, right 1. Up 1, right 1, up 1, right 1, up 1, right 1. So we're going to connect our points. So there's our graph for f of x minus 5. Still 1, still 0. There's no number in front of x, meaning I can only put a 1. No y-intercept, so it has to go through the origin, which is 0. F of x is still the same thing as x. My slope doesn't change. My y-intercept is negative 5. So this graph is going to end up looking exactly the same as this graph, but it's going to be two different shifts. So my y-intercept is still negative 5, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Connect the points. The more points, the more accurate your line is. So again, just like in the last example, both of these graphs look exactly the same, but one is a horizontal shift because it's on the inside, and the other is a vertical shift. So remember, the inside one is the one that's the opposite. So this is -5, so it is considered a shift to the right. It's the opposite. The one when it's on the outside is actually what it says. So -5 means it's going to move down 5. So how are the graphs similar? The graphs look exactly the same. The difference is the shift. How are they different? One is a horizontal shift, and that's this one because it moves sideways. And the other is a vertical shift. And that's this one because vertical is up and down. So when it's on the inside, like this, it's going to go either left or right. It's going to be the opposite of the sign. Whenever it's on the outside, it's going to be exactly what it says. So a minus is going to move down, a plus is going to move up. Even though the graphs look the same, these are considered two different shifts. So let's look at the last few examples. So based on our observations, we're going to compare just the y-intercept. So all I'm looking for is b. Remember the y-intercept in y equals mx plus b. This is my y-intercept. So I'm only going to look at the y-intercept, not the whole thing. So if I have a y-intercept of 1, and now I don't have a y-intercept, that is considered a shift down. I went from 1 to 0 because I don't have y-intercept. So if I'm at 1 on the y-axis and I move down to 0, that's moving down. Remember, we're only focusing on the y-intercept. So if I have a y-intercept of 1, and then I end up with a y-intercept of -4, that is also a shift down. And we'll say 5 units. Because if I'm at 1, I have to move down to 0, that's 1, and then down 4 more spaces is a total of 5 to get down from +1 to -4. So last one, if I'm at 1 and I move to 5, 1 is down here, 5 is up here, that is a shift up. And that's 4 units. This one would be a shift down 1 unit. And that's it. The y-intercept focuses on the last number in the equation that doesn't have an x. Remember that if it is inside the parentheses, it is a horizontal shift. And if it is on the outside of the parentheses, it's going to be a vertical shift.